Hey, I'm Martin here and welcome to episode 6 of my advanced modding tutorial series. This is part 2 of the TileEntities episode. Last episode we explained what a TileEntity was and when to use it. And we also showed a basic example of how to use it. Namely, to use it as a mine. So we can walk around it the first 3 seconds, then after that it's primed and we get close, it will explode. Now it's called a camo mine, and the idea is to make it a mine which you then can right click with a stone or whatever block to give it a certain texture, so it will blend in with the environment. So nobody will suspect it is a mine. So let's do it. So first of all, when we're going to assign a camouflage to that block, we want to have that camouflage be on the server, because the server is boss. Server is going to handle the camouflage and needs to notify every player that that block has a certain camouflage. So in last episode we explained some issues we had, because the camouflage needs to be on the server. However, the client needs to display this camouflage, so we are going to need some data transfer. But let's not worry about that just yet. First of all, I want to right click the block to assign this entity with a camouflage. So first of all, let's do a private item stack camo stack. So this item stack will hold the current camouflage. While we're at it, we can save and read this camouflage from MBT. So it's a little bit hard to do, but let's do it. First of all, you can save this camo stack using a helper method. You can do camo stack.write to MBT and you can give the tag. However, it's not really smart to do that, because if you look at the implementation of this, it will write to this key and these 3 keys, or 4 even. We need to be careful, because if we are going to add more item stacks, you can only do this once, because it will overwrite existing keys. So what we want to do is basically nest MBT tag compound. So you can do that by creating a new MBT tag compound. So you can basically store a MBT tag compound in a MBT tag compound. Tag compounds option. Yeah, I know. So you can do that. And then in the tag we can store that camo stack write to MBT. T. We want to store it in that tag, and we need to add that tag to this main tag. So we do tag.set tag, give the name camo stack, and T was the tag we put it in. So that's that. Now a very important thing you need to know with this is that I can see a null pointer happening right here. This camouflage, if there is no camouflage selected, this instance will be null. This will be null, and when you do a null dot, it will create a so-called null pointer exception. It tries to access this method even though it can't, because it doesn't have an instance to call it on. So to resolve that, we will only write this tag if the camo stack is not null. There we go. Now on the reading side, so when we're going to load this camo stack from the vault data, we first of all need to check if there is a camo stack key in here. So let's do that. Has key camo stack. So this method will return true when a MBT tag compound contains a key, certain key. So let's do that. Only if it has the key. We will try to load it. Camo stack is item stack. There's a static helper method in here. So I can do load item stack from MRT and give it the tag. Now we can do tag dot, and this is not the tag we want to give it, obviously, because the tag was within another tag. So we need to do tag dot get compound tag camo stack. So the tag that thing returns will be used to load the item stack. Now, when the key wasn't there, that means we had a null camo stack, so we also need to assign it null when that's the case. So with this, we've basically made sure that the camouflage will remain when the world will be reloaded. Now for assigning the camouflage. As this instance is private, we can't access it from the outset. We are going to access it from the right-click block method we've used in the past. So we are going to create a setter and a getter. Both we're going to use momentarily. Set camouflage and do that. I could do this, that camo stack equals stack. And get camouflage. There we go. So like I said, I want to set the camouflage when we right click. We want to call this method on right click. So we've got this method over here already. Put in here, return true, so we don't place any blocks when we right click this block. And now we basically need to get the TileEntity, which is stored at these block locations, in this world, at this location. So, whoops, I put it in the wrong class over there. That's a derp right there. I need to put it in the camo mine. There we go. So we can do that by doing TileEntity TileEntity equals world dot. There's a get TileEntity method in there, so we can do XYZ. And you get the TileEntity right in there. Now, if you have done everything correctly, the only TileEntity that should be able to be at this location is this camo mine TileEntity. And I'm going to assume that. If it's not the case, something, some mod or some other thing is happening. It isn't your fault, at least. This always should be the case. Your TileEntity should be at this location. At least for this method, the onBlock activated method. So we've got a camo mine at this place. Now we want to set it to. We want to set the camo to the block that the player is holding, and we could do that by doing set camouflage, the method we created a minute ago, and do player get current equipped item, and that will get the item the player currently is holding. This can be null, meaning player doesn't carry around any item, but which is okay for me. So let's do that. Now it still isn't displaying the camouflage, and it won't ever be, because the camouflage only will be set on the server. Well, actually it's set on both client and server, but as soon as you will relog, you'll lose the camouflage. We need to make sure that this camouflage, you just have to keep in mind that it is on the server. It needs to be transferred back to the client. So basically, as soon as this camouflage gets set, we need to send the camouflage to the client. So there are a few options to go over this, but the best thing you can do is use a override the get description packet. Now this get description packet basically wants to have the packet you're going to send to the packet that contains all the info that the client needs to display. So you've got like item frames aren't really blocks, but if you've got like my charging station for pneumatic rod, it needs to send the item stack that's in that charging station because it needs to display it on the client. It renders it on top of the charging station. And you want to return a packet in here instead of sending the packet yourself, we've done in the past. Because vanilla is quite smart in when to send that packet. Because in our custom method, we can send a packet when the player is within like 64 blocks. But it will only do that when the camouflage changes. But when another player is further than 64 blocks and then gets within that 64 blocks, this packet won't be sent to the client, and that's exactly what get description packet does do. So long story short, we need to implement this. Now we can create a custom packet, but it won't, a custom message as we call it, but it won't extend packet. We need to do something custom, and we can do a we can use a packet that allows us to use the byte buffer we've used over here, this one. And I'd like to create a base TileEntity class because we're going to do this for basically every TileEntity. So let's do a new TileEntity advanced mod, make it extend TileEntity, and make sure that the camo mine now extends TileEntity advanced mod. So basically we make this one extend the base class, and now we can do this, and we're going to send a byte buffer, and you can't do new byte buff really, that isn't possible, that's just the way it works. But you can do unpooled buffer, and that will get you a new instance of it. Now we want to write it, and then afterwards we want to send it, and we can do that by doing return new FML proxy packet. These aren't really things you can research. These are one of the things I've researched on the web to make it work. It isn't really that I researched the code to see how to do it. And we can give it a payload, and we can give it a channel. We can give it a payload buff, and we're going to give it a channel, and we still need to create a new channel. We can't use the existing channel we have already. So I'm going to do a new network handler as well. Description handler. Let's call it that. Now another thing you just need to accept for me, and you can't really know, is this. Do that, and also do public static void init, and do a new channel, and we need to give the channel name. So let's create a private or public, actually public static final string channel. Well, let's do the mod ID, so we do reference, and let's do description after that. So this is the channel name we are going to use. We've used a channel name over here as well, and we just use the mod ID over there. As far as I know, I can't really use this system to be used in the description context. So we're going to do it like this, and we need to give it a new instance of description handler. So basically this class. And basically when we call this init, which we're going to do in our main class, there we go. Let's save it. When that's being called, it will create a new channel and add this channel name. So, and it will this class will be registered as a receiving option. So as soon as a packet gets available on this channel name, it will call this method. That's what this method is doing. It's registering it. So we get this packet back, and we can then read it from here. But let's first finish the sending part. So we need a channel name here, and let's do the description handler channel. So that's how to send the data. I think it's good to do a protected void write write to packet byte buff, and then we can do that over here, write to packet buff. So everything we put in here will be written to the packet and will be sent to the client. It's only from server to client, this packet, and we're going to only be used. It will only be used to update the client, so that's fine. So this is the client side when we read it, and basically what we want is get the TileEntity and call like a receiving equivalent of this. So we do a read from packet. So you'll see some similarities with the write to empty and read from empty, that this is a pair like this as well. Writing data and reading the data back. So we need to get the TileEntity, and for that we need a world which we can get at the client already, because the client always has access to the world, because it's stat from of the client player, though we don't know at which location to look for. So what we need to do is let's write the x, y and z coordinate of the TileEntity with this packet. So let's do buff dot write int, so you can write a integer, and let's do the x coordinates, y coordinates, z coordinates. So these three will be sent with the packet, and I'd like to do it over here instead of over here, because then you don't need to do a super dot write to packet when you're overriding it in our camouflage mine, for example. So writing it to there, and then over here we can get it back by doing int x equals oh, we better can do a byte buff is message dot payload. There we go. So you get the buff back basically. So we're going to do int equals is buff dot read int So this is the receiving side where we're going to read off the location of the TileEntity. We're going to get the TileEntity, and I'm going to do that via our proxy, and there's an important reason for that. Let's put in our common proxy a public abstract entity player entity. Entity player. Wow. Get client player. So this will yell that both these need to implement that, and for the client proxy we can do return Minecraft get Minecraft the player. I think I've shown this already. So this will get the client player. And for the server proxy we can do return null, because it doesn't know of the client player. And you need to do it via the proxy in this case, because a server will crash when you test SMP. So you can do a start server and start client and log in and work with this. It will crash because it can't find the client player class. That's the short version of it. Just accept the fact that you need to access it via the proxy. So we're going to get the world and then the TileEntity. So we do TileEntity equals, we need to get to the proxy, so we do advanced mod proxy get client player. We need to get the world in that player, so we do world object, and then we can get the TileEntity at x, y, and z coordinates. And now it's important to actually check if that TileEntity is an instance of our TileEntity. So let's do if TileEntity instance of TileEntity advanced mod TileEntity advanced mod. We can then safely cast it and do a read from packet, the buffer. This might be a bit complicated. We need to do that again. So we're going to check if it's an instance of TileEntity advanced mod, then tell the compiler like this TileEntity is from this mod, and then that means we can call this method over here. So that's a lot of theoretical stuff, but there isn't much we can do about it. There are hacky solutions in this to return basically the same as what you're writing to your MBT. So if we look at this, you could build the get description packet so it will return what you're writing to your MBT. That is possible, however it isn't recommended at all. The main reason for this is because you're sending far too much data than you actually need. For one, we don't need to have the timer on the client side, and two, MBT tag compounds are really inefficient when it comes to serializing it to bytes and unserializing it. It needs to transfer these strings, even though you only have to send this integer or only this item stack. So that's why I prefer to do it the more difficult but neater way. So let's go into Camouflage and implement that. So we do, maybe just for consistency's sake, we can make this a public void as well. So we can do that. We can write to packet. So we want to write the camo stack, and we can write a item stack to a byte buffer using byte buff utils. That's a really nice class. I taught you about that one already. Write item stack, buffer and stack, camo stack. And the nice thing about this utility class opposed to here is that we don't need to null check it. If you look at the implementation, you'll see it will do that, and if we go into here, you'll see that if the item stack equals null, it will do something else. It will write a short with -1, and when it reads it, it will make sure that the short is equals or is more than 0 before it will try and read the item stack. So that's really neat. So that means we can do this, and similarly we can get it by doing byte buff utils read item stack buff from the buffer. And I think that's pretty much done for the synchronizing part. Well, we still need to make the world know that the TileEntity needs to send its data, its updated data to the client. And you can do that, we want to do that over here. So basically you want to tell it to ask for the description packet, this one over here. So we want to do that as soon as the camouflage changes. So we can do that via the world, and we do mark block for update at the X, Y, and Z coordinates. Now only part left is right clicking the block and then setting the camouflage. No, we did that already. Never mind. So just to prove that the the networking works, we are going to do world is remote. So we make sure that only on the server we will send the camouflage. This isn't really necessary. It doesn't really hurt to execute it both on the client and server, but I think it's neat to do it this way. Now we still can't really see that it works. We can print some logs if we really want to. Writing to packet. I think my hot code replacement is doing weird things here. Oh, that's a bug right there. Okay, that's working. You see writing to packet, reading from packet. So what I did is added this init method. So the problem was that this class didn't get loaded anywhere, so I did that. I put this in there because it doesn't work if I put this one into here, because both client and server call this method when you're on an integrated server, but it's doing funky things. Let's just put it that way. If anyone has a improved solution for this, let me know. Also, be sure to add a shareable annotation above the class. So now it's working. This is just a magic class. Let's just put it that way. So it's working. The only thing that isn't working is the actual camouflage. So how can we do that? If we look at how to texture block, we can see that with the Dutch flag we can do set texture name, and this texture name will be used in get texture name, which will be used in register block icons, and this block icon on its part will be used to in the get icon, which is used in this one. So if you follow it all the way back up, you can see it will come down to a eye icon instance. And For the most part, when we have a block in the world, this method will be called, and thus that will call this, and it will follow down the route. But we could override this and return the icon we want. The icon of the camouflage block, for example. So the parameters in here are, this is basically the world. If you look at world, the world implements iBlock access, which has these methods we are familiar with, and we only need to have the get entity, so that's fine to not have the actual world. So we can do world, X, Y, Z, and the side. So like every side of a block has a different icon, or it could be the same icon, but we could make a different icon. So if you look at the crafting table, you could return a different icon for a different side. And same goes for a piston, for example. So let's first of all get the entity, and the same goes for what I said over here. In this method, you should always be able to get your entity. So let's do that. And we can get the camouflage stack. Or let's just call it stack equals get camouflage. Now if the stack is not null, and if it is null, we want to return the normal texture of the mine. So let's do super get icon and do that one, world XYZ side. Now another thing you need to remember is when I right click the block with a normal item, so like a piece of coal or a stick, we don't really have an icon for that, and we actually don't really want to return an icon for that. So another prerequisite is that the stack needs to be a block, and you can check that by doing if the stack, the item it contains. So Parma has discussed the idea of item stacks already, and you should be able to figure it out from there. Now there are certain item classes, and for the blocks there's a special one called item block. So you can do instance of item block, and if you look at this class, you'll see it as on item use. So on right click on a block, basically it will place down a block, and that's basically what that item is doing. Now another thing you might have seen is this field, and this field contains the block it's holding. So we can use that. We can say block equals item block stack get item, and do that. So this will get the block that's in that item stack. And having that block, we can do get icon. And we should use the non block access one, because if we do that, if we do the opposite, so if we've got a camouflage block that was camoed like a camo mine, then we would get this error, because we're going to assume that the entity we get here is the right thing. So just to be safe, we're going to do get icon to respect everything. And this get icon method usually is called when the item is being rendered. So when you have a crafting table in your hand, it will call this method to get the icon when it's in your hand. And the first method is the metadata, I think, or I've turned them around, but I think it's the metadata. Site metadata. Okay, first site. So let's do the site and the metadata. I haven't gotten into that, but most blocks of their metadata is the same as what's on the item damage. and I'll show that in a second. Or like right now, I guess. I think we're ready to do it. Oh, I think it worked already. That was a spoiler right there. Wait. That's another thing. If we do this, right click it, you won't see it until I place down the block. But it does work. Ooh, boom. That wasn't mine. The reason for this is that Minecraft's rendering system is quite efficient in that it will only update when a change happens in the chunk. So when we place down a block, it will update the chunk and it will have to re-render. But if we right click that block, the chunk doesn't notice that it has changed. So until another change happens, it won't update. And we can force an update to happen by adding a little bit of code. When we receive the packet, because we want to do it in here, because we want to update the rendering of the chunk on the client side. So we're doing it right here. We can do mark block range for render update, and it does want to have a block range, but so multiple blocks, but if we put it in twice the same coordinates, that will work as well, and that will just update one block. As you, by the way, can hear, I'm recording this in another day, and I've gotten a mechanical keyboard in between, so that's probably why you can hear a sound difference. But back onto the topic, when we add this and we place down our camo mine, it will update right away, so that's that fixed. Cool. And this concludes part 2 out of 3 of the TileEntities tutorial. Next episode we'll be discussing how to work with inventory and sided inventory, and after that episode I'll show you how to do a inventory with a GUI. The following episode will come shortly after this one. I've got more free time, so you can look out for that one. Probably tomorrow or maybe Tuesday. We'll see. So, for now, see you all next episode, and bye bye.